Okay, and we are live. Hello, good afternoon, good morning, good evening, everybody. Thank you for joining us for this webinar about smart meters and about how IoT has changed up a gear in the utilities market. And really, as per a number of recent articles on the RCR website, I would suggest this session is also about why smart meters are the most important play in the whole IoT game. Because for society and for the planet, smart meters are the essential network and data hub for the whole energy transition. And for IoT makers and IoT operators, they are just about the only, or certainly one of the very few sectors with the kind of muscle to justify an entire infrastructure rollout. And so if innovation is happening anywhere in IoT, it is happening here with smart meters. So we will get into some of that today. My name is James Blackman. I'm an editor with RCR Wireless, and I'm your chair for this session, which is brought to you in association with Kigen and Telit Cinterion, which separately and combined have got most of the IoT market covered and are both driving innovation in the smart meter space. And we will hear from both companies shortly. Some housekeeping just to begin. This session is being recorded, and the recording will be available on demand later today. Slides will be available to registrants after the event. We will have time in the second half to take questions. I'd encourage you to submit those at any time throughout the session using the Q&A dialog box in the platform, and we will get to them as we can. A note as well, the panel will switch their cameras on and go to video for the Q&A section. In the second half, we will just run with audio and slides until that point. Okay, so the first thing is to introduce our panel. We have four fantastic, deeply knowledgeable, highly opinionated speakers today. So I would like to introduce, in order of appearance, Matt Arnott, who is a principal analyst at Transformer Insights. Matt is an experienced analyst and consultant who specializes in quantitative analysis and forecasting of new technology markets. He has a close watching brief on smart meters, and Transformer Insights, I would suggest, has established itself as the premier analyst house in the IoT space. I'd also like to introduce Loic Bonvalet, who is Senior Vice President for Solutions and Marketing at Kigen. Loic has 20 years of experience in the IoT and end-to-end markets, covering product marketing, technical sales, application engineering, R&D. Kigen, in case you don't know, once part of ARM, is a crucial player and innovator in the IoT space for SIM, identity, provisioning, and security. Fabienne Petitgrand is Chief Technology Officer at Ubic. Fabienne heads software development and technology strategy at Ubic, and is familiar on the IoT circuit just about every IoT show I turn up to. And Ubic, for reference, is an emerging power in the AMI and private LTE market, offering hybrid weightless and cellular for utilities. And it is won just about every other tender going in its home market, and is a developing play in Europe, North America, and elsewhere. And finally, Neil Bosworth, who is head of vertical segments at Telit Cinterion. Neil's in charge of vertical marketing and strategy at Telit Cinterion, which is the biggest IoT module maker in the West, and a whole lot more besides, also offering MVNO connectivity, SIM identity, security services, and so on. Smart energy and smart metering is a key part of Neil's remit at Telit Cinterion. So welcome all. Thanks for joining us. We'll hear from each speaker in just a moment. A quick look at the agenda today, just so everyone is aware of the order of service, as it were. Each of our panelists will present for 5 or 6 minutes on the subject of smart meters. I will let each of them introduce themselves, say a little bit more about themselves and their companies and their views on the market. We'll then go to this Q&A session in the second half. We're down for an hour, so we should have plenty of time for questions. Like I say, please ask as we go, and we will get to them after the presentations. Something quickly about RCR Wireless as well. This is boilerplate stuff, but to give you some background, RCR Wireless has been around since before the dawn of time, or at least as long as the mobile industry anyway, since 1981-82, and is your go-to for news, interviews, insights about all things wireless. RCR now integrates enterprise IoT insights as well as in-building tech. So it is your one-stop for news and views on digital change within the wireless sector itself and how digital change is being sold to the rest of the world as well. And the target audience is, well, everyone in kind of tech and telecoms, really, and every enterprise vertical buying from tech and telecoms. And you can find us online variously. Just a note as well to say that we write lots of reports, and this session will be followed by a long-form editorial report, which will summarize and extend the discussion from today. And this slide actually shows a bunch of stuff that were published mostly by Enterprise IoT Insights through to the end of 2022. The new report on smart meters will, I'd suggest, more closely follow the story that all of these tell, perhaps, than the traditional RCR fair. Anyway, these are all available online. They're all free to download, so look them up. Just a quick note as well that we have a big event coming up, the Industrial 5G Forum, which is online on November the 7th, and we'll cover some of the aspects from today's session, particularly about private networks and industrial IoT, and you can find that easily via the RCR website. Okay, back to the agenda. So we start with Matt from Transformer Insights, who will kick us off with a kind of, I guess, a kind of a SWOT analysis of the market about the key trends and opportunities and where it's all going. So Matt, thanks for joining us. Over to you.
Thank you for the introduction, James, and hello, everyone. As James said, I'm Matt Arnott. I'm an analyst at Transformer Insights, where I'm responsible for all things forecasting, really. For those of you who aren't familiar with our work, we're a technology research consulting firm broadly focused on IoT, but also the greater world of digital transformation, which include things like artificial intelligence, edge computing, robotics, and so on. As part of today's session, I'll be giving a quick overview of the state of the market and how the future looks for smart metering, using some fairly high-level data from our very granular IoT forecast, of which smart metering represents a small but significant part. I should start off by saying that smart metering is a fairly mature market as IoT goes. Many countries have already reached full deployment of electric and gas smart meters, or are soon to do so. In fact, we reached 50% of all homes with electricity having an electric smart meter in July this year. This is causing some quite noticeable changes in where smart meters are being deployed. Shipments in previous years were very much concentrated in developed countries, but the developing world is starting to represent a significant market, particularly for electric smart meters. So on our chart to the left here, we're showing the regional split of electric smart meter sales out to 2032. And as an example of this shift away from developed countries, we can see that Latin America will become a bigger market than North America next year. And the traditional trio of leading regions, so that's North America, China, and Europe, will represent less than half the market for the first time. We can also see that there's significant growth in Southeast Asia and India and South Asia occurring in the next few years. Zooming out a bit from this chart and thinking about the market from a more scale perspective, many countries that have so far been resisting a smart meter rollout have been spurred on by recent concerns about energy costs and energy security. So we can expect an uptick in growth towards the end of the 2020s as a result. Changes are coming from a communication technology perspective as well. NB-IoT is finally starting to come in now outside of China, but in Europe, 2G shipments still remain that much higher. That situation is going to be very short-lived. Europe had an 89% share of global 2G electric meter shipments in 2022, but we're expecting there to be almost none being shipped in 2029. China has been leading the way for NB-IoT meter deployments for many years now, and that situation is changing. China had an 83% share of NB-IoT electric meter sales in 2021, but that will have dropped down to 48% at the end of this year. A lot of that share being taken up by Southeast Asia and Europe. The discussion around smart meters often defaults to electricity meters, as I've rather done here, but on my next slide, I've got a bit of an overview on gas and water meters as well. So here we can see a comparison of gas and water smart meter sales over the course of our forecast. Historically, gas smart meter sales were higher than their water equivalents, but that trend reversed in 2021, just off the left of this chart, and we're only going to see that trend continue, really. This is all despite the high gas prices that we saw pretty much throughout 2022, and it's more of a reflection on gas smart meter rollouts finishing in developed countries, whilst developing countries are beginning their rollout of water smart meters in comparison. Of course, natural gas usage as well has a much more limited geographical range, with gas use at home mostly found in developed countries, household water use, of course, being almost universal in comparison. From a more long-term perspective, water stress was a topic that came back to the fore again last year, following some fairly severe droughts throughout a lot of the world. And this stress is going to translate to an increase in desire for monitoring of water use. And that trend is only going to accelerate. Unfortunately, we're looking at roughly 2/3 of the world's population being expecting to face water stress by the end of 2025. And this is fairly indicative of recent trends that we've seen in IoT as a whole, where sustainability has become quite a large market driver. Energy independence has also become a more relevant topic in the past 18 months. That, combined with a huge number of net zero emissions targets, will mean that gas use will need to be that much more heavily monitored. But there will also be a gradual move away from the use of gas for domestic heating, which will ultimately reduce the market for gas smart meters over a longer period of time. Hopefully that quick overview of some of the broader trends at a global level was a good way to start off the session. And with that, I'll hand back to you, James.
Matt, thank you. That's great. Really interesting. Perhaps we'll pick through some of those stats in a moment. But for now, we're going to hand over to Loic Kigen, who's going to talk about eSIM, I guess, is the cornerstone of IoT scalability, I believe. Loic, I'll leave it to you to explain.
Yeah, thank you, James. Yeah, great to be here and to present some thoughts on metering and Kigen. So yeah, we can move on to the next slide. Yeah, so just a brief few words about Kigen. So Kigen is focused on securing connected devices at large, right? And we do that notably through the mean of eSIM and iSIM, and also for cellular devices. So to achieve that, we have several offers and services, right? We have a SIM, eSIM, iSIM OS that can go into different form factors that you know for the SIM, plastic SIM, solderable SIM, integrated SIM. And we have the ways to personalize those SIM cards, whether it's in the factory of one of our partners for a discrete SIM card, or working directly with chipsets, with module maker, with secure IC to personalize and provision cards. And even now we see a recent trend towards enabling more and more the actual OEM, sometimes the smart meter manufacturer, to actually go and provision their cards for their deployments. We do offer also eSIM RSP solutions for the in-field management. So Kigen has services for RSP for M2M, consumer, and working actively on IoT RSP. We're still chairing the GSMA group that is developing the IoT SGP32 specifications. And finally, the last bit in the bottom right corner is the applicative security offering. and revolves today mostly around IoT safe, and that is really leveraging the hardware security that a SIM, eSIM, or iSIM provide for applicative use. That is that hardware security is mandated, let's say, to secure the telco and the communication, but we can also use it for the application. For example, give a unique identity into a cloud, into a backend, to a device. So we can move to the next. So cellular IoT specifically for smart metering. I think we see, thanks to notably Matt's figure, right, a quite significant adoption of smart metering at large. And cellular is not the only way to achieve connectivity for metering, but that's one way to achieve a pretty flat and simple architecture, especially when cellular goes all the way to the endpoint, to the metering point, or to a hub that is going to connect to several meters. For example, in the case of the UK deployment, you have a hub that connects to a variety of meters, gas, electricity, and so on. So to achieve, I would say, deployments effectively, meter manufacturers like to remove from the equation a plastic SIM, right? Because plastic SIM don't necessarily meet the necessary environmentals, regulatory requirements. It's not necessarily as durable as it should be. So a soldered eSIM or an integrated SIM is more appropriate in that case. Now, with eSIM and iSIM comes the need to be able to personalize and load the right connectivity in each meter. For, say, a meter goes to a specific geography, it needs a certain connectivity supplier to be available on that meter, and that's among the things that we work closely with the manufacturing partners to enable. So, and once the device is in the field, typically also in metering, you have a need to really have long life cycles, right? Up to 20 years, for example, in some cases. And so the service provider who actually deploys, or the utility who deploys those meters, have to find a way to ensure connectivity for this long period of time, which is not something typically the MNOs support, right? They don't typically sign 20 years contracts. So you need the ability to switch provider during lifetime, right? And that's where RSP, remote SIM provisioning, comes in and really help to deliver that function. And again, this can work on classical eSIM, solderable eSIM form factor, or already today on some integrated SIM form factor as well. So we can move on to the next. So some of the drivers for adoption of eSIM in smart metering that we can see. One of them is the shift from proprietary to standard-based solution. That is notably in the sense of, for example, in some deployment, you have a combination of transmission technology. You might have CPL plus cellular, or mesh plus cellular, and it's very adapted in some deployment, but sometimes if you dealing with, for example, gas and water meter, which do not have easy access to power or to actually a wire to transport the data, right? Like you have in electricity, a meter on a single charge battery with cellular connectivity is what's making sense. And that's what we've seen heavily used, notably in China with NB-IoT, but also now coming to more and more markets across Europe and the Americas. So again, in China, we've seen quite a lot of adoption around NB-IoT. In the rest of the world, we see typically a mix of CAT-M and NB being used. And one also driver, which I think is important, is this allows a better, I would say, control over the consumption, right? And potentially, as Matt was mentioning, we'll deal more and more with stress, notably to water access. And we might come down to actually pretty strict measures for consumption around water. And this can be enabled with metering solution that report daily usage, notably, right? So that's one aspect. Another interesting aspect is 25% of the water, for example, in France is lost in distribution, right? If you monitor the network and market, the water network better, we can hopefully reduce these losses during distribution of water, of clean water to the end users. Last point being, there is always a price pressure on metering assets, right? Most governments, regions, cities want to be very careful about public money spending, and thus, being able to come to the best cost point possible for the meter while meeting the requirements is really important. Next one, please. I won't go so much in detail here, but that's some of the eSIM numbers that we've seen, right, from the research that we've collected over the years, with the overall market dollar opportunity estimated at 16 million plus, a strong growth of IoT and M2M eSIM profile download in 2022. We are now working in multiple, I would say, trials for the new specification IoT RSP. And finally, the number of units to be shipped by 2028 using eSIM or iSIM, we estimate a total of 6 billion. So it becomes a prevalent number of eSIM and iSIM enabled devices. It's really now common in our smartphones with vendors, and it starts also to be the case in some of the IoT markets, notably metering. Kigen offering, notably really specifically applied to metering. Again, there is the RSP aspect that helps to manage the in-field management. There is potential to use IoT safe also for metering security. Quite often the security in metering system has been through proprietary, quite complex systems. So I think there is an opportunity here to simplify and to rationalize some of the security deployment in some cases, notably for the greenfield deployments. And one topic we'll, I'm sure, discuss a lot with James and the panel later is the problematic of personalization in factory, right? Not pictured here, but really something that we spend a lot of time and energy on those days in metering, because there is a strong expectation to simplify the logistics of establishing connectivity in meters. And there's still a lot of potential improvement to be done to simplify this supply chain. All right. I think that's it.
No, thank you. That's perfect. Well done. Thank you so much. And we're going to move on in interest of time. We're going to move on swiftly, and I'd like to introduce Fabien Petitgrand, who's in charge of technology and strategy at Taiwan-based Ubic. Fabien, it's over to you.
Thank you, James, and thanks for having me. So yeah, I'm Fabien, CTO of Ubic, and yeah, we describe ourselves as a leading solution provider for AMI connectivity and utility connectivity in general. So if we go to the first slide, actually, this is to describe what essentially got us started. So Ubic was founded in 2016 and is since 2018 AMI service provider to the sole utility company in Taiwan called Taiwan Power, which started its smart meter rollout in 2018. So we are providing the communication infrastructure piece of the AMI. So one piece of the AMI is the meter itself. We don't provide meters. Those are actually supplied by different smart meter vendors, but those meters are not communicating. Then another piece is communication infrastructure. So from the fan or the NIC card that goes into the meter to the potential DCU or gateways needed to collect the information, to the server-side database and head-end system. And then we are responsible for pushing that information to Taipower's MDMS, which is again a separate piece of the AMI infrastructure. So there are 3 layers in the tendering that has been done for Taipower. The MDMS is a single one. The communication infrastructure which Ubique is the largest provider of, but there are other companies, 4 or 5 as of now, and the smart meters themselves with 6 or 7 smart meter vendors present in Taiwan for those deployments. So as of today, we have close to 1.2 million meters under contract. Some we are still deploying the connection for those. So we will reach a number in the field by end of 2024. As of now, we have more than 700,000 already deployed and running in Taiwan. So we are providing the equipment, the software, as well as the service to operate, maintain, and provide the data to Taipower. So in that particular deployment, we actually use a mix of communication technologies, always wireless, because that's the heart of everything we do at Ubique. But we use a mixture of non-cellular LP1 technology. So in this case, is weightless, an open standard that we have implemented and deployed in a licensed band in Taiwan. And we use cellular, so NB-IoT, and a little bit of LTM, CADM1, as a complementary technology for covering when it doesn't necessarily make sense to deploy our weightless base station or DCU data concentrator unit, as it's called in the MI world. So maybe moving to the next slide. This project have allowed the company to grow, and we have actually recently also announced the acquisition of New Zealand-based MIMOMAX. So this acquisition has been completed in July. And this now gives us a pretty global footprint in with offices in the US, Canada, France, India, Taiwan, Japan, New Zealand, and Australia. And MIMOMAX gives us access to their strong customer base, especially in the US, North American market, for connectivity for the utilities. So the team now is 150 people strong and developing markets outside of Taiwan aggressively now. So if the next slide, maybe just to show then Ubique product offering. So since the acquisition of MIMOMAX and the development we have done, so we have a wide range of connectivity solutions. So from the mission critical type of connectivity, so those radios on the top, like the one called Tornado, this is typically to operate in private spectrum that utilities might have. It's for narrowband communication, so that's 12.5 or 25 kilohertz channels delivering more than 1 megabit per second. So those are very high efficiency radios offering less than 3 millisecond latency for the higher end of the use cases of utilities. So think about telesurveillance, for instance, where you do need to shut down the lines with a very, very low latency. Then we have, I would say, the less critical connectivity solution, and smart metering could be considered somewhat less critical connectivity. So we have the weightless base station that we have deployed with great success in Taiwan. We have more than 2,000 base stations deployed all across Taiwan for our IMI deployment. We also actually have released last year our first, we call IoT base station. It's actually a full-fledged 3GPP cellular, so LTE base station, or eNode B in 3GPP terms, but really tailored to the use cases of utilities. So it's designed for deployment in fairly narrow spectrum, 1.4, 3, or up to 5 megahertz bandwidth. And it can operate in different license bands, so the commercial bands, band 8, band 28, band 3, or private LTE bands, which are actually getting a lot of traction in the US. So we have version operating in the Enterix band 8, which is band 106 right now. Also operating in the NB-IoT only band 103, which is leased to utilities by Select Spectrum. As well as very recently, we announced our collaboration with Ligado to support their 1.67 gigahertz TDD 5 megahertz block, which they also intend to provide to utilities to deploy their private LTE networks. So we are to release also a base station operating LTE CADM1, TDD 5 megahertz specifically for that band and for those utility use cases. And more recently, we have also released actually LTM CADM1 base station, but operating in the unlicensed 902 to 928 megahertz band in the US. So it got FCC certified in May. So it does actually mean that you can connect existing LTM devices that are traditionally operating or supporting band 8 directly can connect to that LTM base station operating in the unlicensed band without any hardware or even software change. And that's something that can allow utilities to actually extend the coverage, potentially if they use cellular connectivity and they don't get the coverage from their preferred operators, then they can actually fill the gaps with free run in unlicensed band, which is a band that they are very familiar with because as of today, especially in North America, most of the AMI and smart meters are using unlicensed band for their connectivity. So be it Itron with their mesh technology or Landis & Gyr, they traditionally have been using mesh technology, even though there is a strong push to private LTE right now. Or it could be a choice as well for utilities that really want to go to cellular and to private LTE, but that do not have necessarily the scale or the capital to really engage with very large players. You know, think Ericsson, Nokia for the base stations, which are actually coming at a premium for utilities that may only deploy in 3 MHz bandwidth. So free run could be an alternative for that as well. It's a fully 3GPP compliant solution that we are actively promoting and that is attracting a lot of attention. And we've demonstrated already, we've tested with some smart meter vendors like Itron. We've tested in their lab, demonstrated that integrating that with Verizon backhaul on that base station. So offering quite a few possibilities. And obviously to Loic's point, when you start to integrate free run or those base stations along with public networks, then comes the question of how do you move from public to private networks and how do you manage a SIM so that it can connect to all those networks. Now we provide as well NICs or fans. So those are the essentially communication modems or modules that go into the meters. So we have modules supporting wireless, we have modules supporting LTM for the different bands, even private LTE bands. And we have versions supporting NB-IoT, as well as combined solutions now. So we are about to release a combined solution, which is using a single chipset to support both wireless and NB-IoT to give you the full flexibility when you have no coverage from one or the other. And we are also to release LTE routers specific to utility use cases. So it could be to collect smart meter information or capacitor banks or whatnot. And finally, we are a software provider as well. So we provide a head-end system, and we have actually the largest deployment by far, which is the one we run in Taiwan with more than 700,000 meters. And we are processing more than 80 million meter readings every day because those are electricity meters. So they report readings every 15 minutes, and you need to deliver them within 15 minutes. And then they have extra readings every hour with some additional information, instantaneous voltage, frequency, instantaneous current. And then we also have a daily report called the billing, which is the midnight, which is actually used for billing purposes.
Fabien, I'm going to stop you there if I can, just because of the time. I know I think you may have a couple more slides, but I think that there's a lot in there, if I may, and we'll come back to some of it. But just to
so maybe you can move quick to the other one was just to show some picture of deployments and the fact that we have solution for deployment and coverage planification to where do you want to place your base station, etc., for deploying AMI networks. So that's
Fabien, let me interrupt because I want to give Neil time to present his piece, and these slides will be made available after this event, and obviously we will talk, and we've got a report coming, and we will get into some of that stuff if you don't mind. But thank you so much. That was really fantastic, and you have, I mean, there's a lot going on in there, so it's a really kind of captivating kind of story. So, but without further ado, Neil, I'd like to hand over to you. And really, if you want to know anything about IoT, then Neil and Telit Cinterion are the places to go. So, Neil, it's over to you.
Thank you, and hello everyone. It's great to be here. I'll be prompt and I'll be pretty high level. So if you'd like to move on to the next slide, please. So firstly, a little bit about our company. At the beginning of 2023, Telit combined with the IoT experience from Thales, forming a new company, Telit Cinterion, with the Cinterion word coming from the IoT product branding from Thales. And both companies have got a long history in IoT, going back into the 1990s. And excuse me, our combined goal was always industrial IoT, providing cellular connections and services to the most critical IoT applications. And energy and utilities have long been a focus, and we've got a significant heritage and footprint in this market, which we really continue to focus on and address with Telit Cinterion. Okay, next slide, please. But as we're talking about smart metering today, I mean, we've been active in this area since the very first AMR deployments, you know, the automatic meter reading deployments, when it began a long time ago. Reliably connecting smart meter infrastructure is a huge challenge for DSOs and utilities and integrators, and they're faced with a bewildering choice of connectivity options, each with its own strengths and weaknesses. And we're now either seeing brand new deployments or second phase updates, because there's a natural refresh life cycle across all continents. And these rollouts are really driven by the need to preserve or manage the available energy and move towards more flexible grids, which in turn require more flexible and smarter homes and appliances. But across these deployments, decisions really need to be made about the most efficient and secure means to connect them throughout their long duration of service. And the choice of connectivity scheme, and we've heard a few today already, and sometimes it's driven by legacy. So in the US, for example, we heard earlier that the vast majority of meters were connected by RF mesh technology. They may look to build on this topology, but we also see a trend going to more towards cellular. Europe has seen a lot of PLC rollouts, but it's mainly cellular. And in Japan and India, a combination of short-range wireless technology along with cellular, with emerging Asia looking towards cellular for fresh deployments. I won't go into all the reasons behind this, but as a rule of thumb, cellular communication provides a key role in all topologies, regardless of the communication technology present at the meter. And this cellular connection needs to work reliably. And when you consider gateway or mesh use cases where one gateway can be responsible for thousands of endpoints, this cellular connection is really key. Okay, next slide, please. So at Telit Cinterion, we've got many touch points in the smart metering landscape, with millions of meters connected using our cellular modules, which is creating the vital comms link. And today, the popular technology choices are Category M, Narrowband IoT, or Cat1. But it doesn't end there. We're delivering tools and platforms to enable lifecycle management for smart meter deployments, to take advantage of eSIM technology subscription management for manufacturing and in-field use cases, offering the ultimate flexibility in choosing the most appropriate MNO. I won't go into this because Loic's mentioned a lot of it already. We provide device management capabilities to ensure security and firmware upgrades at scale. And we work also with short-range technology for smart home, and we're also working on mesh technology to complement our cellular experience. And we even work with the industry to develop communications gateways and cards. Okay, next slide, please. Here I mentioned some of the pain points we look to address across the smart metering ecosystem, the DSOs, the meter solutions providers alike. So rather than just supplying cellular modules, we kind of understand the pain points to help tune our portfolio and sort of tune our product offerings. We're in the unique position to be able to provide solutions, both hardware and services, covering multiple disciplines, with our focus really being on security and reliably connecting the meter to this head-end system. It's a complex ecosystem that has many challenges and constraints, with the added complexity of being a prime cybersecurity target, whilst also the additional complexity of being extremely cost sensitive. And finally, to my last slide. So, as I said, rather than being a component provider to the industry, you can see we've got a multi-layer approach. Our cellular modules are embedded in millions of meters and gateways or concentrators, packed with features to help meter manufacturers control their costs whilst providing a range of module technologies to cover the wide demands of global metering rollouts. Subscription management enables the eSIM to provide value across all stages of a meter's life, from manufacturing to the active service, and combining on it or embedding the eSIM with the module gives us a clear path to help our customers migrate to iSIM. And this is an example of addressing demands of an industry in terms of SKU control. We are in fact an MVNO, which can sometimes be a good option for AMI. We use this technology to complement subscription management, and we provide full custom hardware solutions too to the industry. We're not really in the business of building Telit Cinterion branded gateways or concentrators. Moreover, we have the communications and product expertise to provide a solution, a hardware solution and software beyond the module, encompassing our product and services technology. And then very finally, with our Thales heritage, remember I said some of us came from Thales, we look towards key management, covering use cases from in-factory provisioning and key injection and credential management. So that's me. I'd like to hand back over to James and we can continue the discussion.
Neil, thank you so much. That's brilliant. Okay. We have got some questions coming in. Thank you for those. We will come to them in just a moment. At this point, I would like the panelists to switch their cameras on. And I will stop the slide share. You should hopefully see us all. Hello, everyone. How are we doing? So yes, some questions are coming in and we will get to those shortly. I mean, just maybe to start, and there's a couple of points here. There's a question here about the attach rate on cellular, Matt, which I might come to you for, but just as context, I mean, perhaps the cellular industry talks about meters in this way, but it's as if it is a cellular market, but cellular is but a fraction of the connectivity mix, right? Just talk to us about that, and at the same time explain the importance of this market to IoT, if you like, and to cellular IoT, because it is the kind of a market. I mean, we've written a story, we published a story where you called it a kind of a market maker. So just explain both those kind of aspects if you can.
Yeah, sure. Well, I think Neil summed it up quite well actually just then, saying that really it's a market that's quite highly reliant on cellular in every single country pretty much, but it does vary massively, of course. The early rollouts, particularly in Europe, weren't that heavily reliant on cellular on a meter by meter basis. A lot of them reliant on PLC, and you'd end up with maybe 5–10% that were perhaps off grid. If you were a bit further away from a concentrator, it doesn't really make sense to use PLC in those cases, so they were a cellular meter. So a small number of meters. The concentrators, of course, were almost always cellular, so you're reliant on cellular at some point in the chain. It's just it may not be for every single meter. The attach rates, I think I said there, 5–10% in many of those countries. In 2023, our forecasts, we're saying about 25% of all meters have some sort of onboard cellular connection. That varies hugely by country. So China is very heavily reliant on NB-IoT. Here in the UK, we have a lot of cellular communications on our meters. Big variance by country, basically. Looking at it from a global perspective isn't always that handy, but it is moving more towards cellular in general. I think at the moment we're looking at, so there's 25% cellular installed in meters, but you're looking at 40% of shipped meters, 30–40% have some sort of cellular connectivity on board. So it's definitely moving more towards the cellular side of things, but it's quite a market with quite a lot of inertia, obviously. To that market maker kind of perspective, we're obviously in a time where there are quite a few new connectivity technologies coming through, a lot of new networks being set up for NB-IoT, LoRaWAN, those sort of new technologies coming through. By definition, those networks are being set up without necessarily having any big customers in play. And we have seen a few networks disappear overnight, basically because they don't have the interest out there to really continue. Having a smart metering contract can basically sustain those networks for 10, 15 years, right? So signing up to one of those contracts can really make a market. And from a utilities perspective, that's sort of quite advantageous. You have a more symbiotic relationship with the network. You have more say, perhaps, in how the network is run. Downside, of course, being there may be limited alternatives if it's quite a more of a niche new technology. End users as well could really advantage for that because there's some element of security in that network, right? So it's quite a benefit for network operators as well if you can effectively say we're going to support this network for 15 years because this is our customer base. That is a sort of double-edged sword though, because we've got things like in Europe where the 2G networks are starting to be switched off in many countries, but not all countries are doing so because the 2G networks are important to keep smart meters running, right? So sometimes it may be a downside for network operators having to keep the network running longer than it should be.
Okay, and thank you, Matt. And Neil, perhaps we bring you in just around the cellular mix and how that's developing. I mean, because you take a market like France and Italy, you know, which are power line markets, and they presumably stay that way. But the point you're making is that somewhere in the mix, cellular will come in, and then presumably as a counterpoint in newer markets in Africa, some of the markets that Matt referenced where the growth is coming, this will be the default choice. Is that correct? Would you say that kind of analysis?
I would say that we see cellular considered in every country, and as Matt was saying, and as I said earlier, if not directly at the meter, it will certainly play some role in the ecosystem. In France and in Spain, there's quite a lot of PLC today. In Italy, actually, it's a mix. There's quite a lot of narrowband IoT in Italy, especially with the gas industry. And then we look forward to the rollouts that are going to be coming across Europe. Germany is the next hot topic, where today there's a limited rollout of gateways for high consumers, and they're all based on cellular. Maybe I lost track of the question here, but I think I honestly think what we're going to see going forward is more of an approach of hybrid networks. We start to see it with PLC today, because I think in the PLC world, it does have its weaknesses along with every other technology, and we're starting to see a hybrid approach combining PLC with RF. And I think we'll also start to see much more of an overlap between cellular and short-range mesh technologies and ISM band technologies, because both technologies have their benefits and both technologies have their weaknesses. And the trick is, I think, going forward, is to try and pluck the benefits from all the technologies and combine them together.
Yeah, okay. And Fabian, I mean, that seems to be your message, taking your experience in Taiwan and complementing Weightless with NB-IoT and cellular here and there. Just there's a question here about the pros and cons of Weightless versus cellular LP-WAN technologies. Just can you sum up for us?
Yeah, well, I will concur with what Neil said. So, of course, we have implemented Weightless, and we are a promoter of the technologies. So that's in the LP-WAN space. So it's also a narrowband, low data rate, long range technology. So it's not a mesh technology. You can compare technologies themselves. So Weightless has similar link budgets than you will get with NB-IoT or LoRa, but it does provide the network management and scheduling that gives you the capacity required for electricity metering network, for instance. But NB-IoT and LTE-M are equally good technologies. They might be a higher cost as well. But the thing is, the main difference I will see is with Weightless, and that's kind of true for unlicensed technologies, is that you can always deliver the coverage and the SLA to the utility. Whereas in the cellular world, if you rely purely on commercial networks, then you will always face issue with coverage. And one thing is in Taiwan, for Taiwan Power, actually, the tender was not mandating any communication technology. it was really requiring SLAs. So 2018 was 95% of the meter reading would need to arrive in time. Back then, the in time meant within 4 hours. And now we are up to 96.5% needs to be arriving in time meaning within 15 minutes. And in the end, the only viable way to achieve that at scale for millions of meters is indeed an hybrid type of topology. So in our case, we use wireless for the vast majority of our devices, and we complement with cellular. And sometimes when we start to complement with NB-IoT, and we run into the problem of capacity of NB-IoT, because it has very limited capacity on commercial network when they assign only one channel, then we can kind of fall back to weightless or LTM. And some other vendors will kind of do the opposite and rely primarily on cellular, but they always have to complement with something. You will not get the coverage required to meet the SLAs, which are more and more stringent, as we move from AMI 1.0 to 1.5 or 2.0, with more readings, more exchanges, more bidirectional communication. You have, for the most cost-effective solution and to deliver the SLA, you do have to have those hybrid schemes. So it's not just a technology comparison, it's how you deploy it and how weightless, and for that matter, mesh or LoRa or those technology, you can always deliver the coverage. You can throw another gateway where you need to have coverage. You can't do that easily with cellular, at least not on commercial bands. And that's why a lot of utilities are trending towards private LTE. So using cellular for its versatility and its ecosystem and large supply chain, but deploying and controlling your own network where you can control its configuration, how it's operated, and you can dedicate it to that use case. And in that case, cellular is a very viable option as well. So I totally agree. And that's actually why we provide solutions in both markets. And we, to Neil's point as well, we actually are going to release a single chipset supporting NB-IoT and weightless. So you can have kind of the best of both worlds, or you can have more flexibility in how you deploy. And that's why we like to, we deploy wireless in licensed bands, and we make available cellular in the unlicensed band in the US, because those technologies are not necessarily that different either. And you can have hybrid scheme to deliver in the end what the customer needs. And the customer is utility needs their meter reading, and they need a very large number of those.
Okay, and Lo, just to bring you in, just to, I guess, to switch back to the cellular story and the story of eSIM and how that's changing things. Just talk around that, and specifically, if you can, talk around. There was a question that came in. I think you answered, but I think it was an interesting question around eSIM versus iSIM and Kigen's position. The suggestion was that yes, you appear to be favouring eSIM in meters. Is that right? Can you talk around that and just more general opportunity with eSIM?
Sure. So yeah, out of these 25% that are using cellular technology, I would say I see 3 waves which happened, right? The first wave, which was just the first generation, integrating a cellular modem into a meter and trying to make the best out of it, right? And learning how cellular works for metering. So that was, well, most of the time in type of concentrator or gateway and so on, and then an alternate technology behind. But then you had maybe a second piece, which was the explosion, notably in China, of NB-IoT and the solderable SIMs and potentially now solderable eSIMs, really capable of managing multiple connectivity profiles and being updatable pretty much, right? So that's really one of the phase we are in cellular. That is, most of the new tenders require clearly a soldered SIM, right? And then comes the question of, do we take the risk of fixed, connectivity for the lifetime of the product, or we really need to bake in the multi-profile capability? And I think most of the big players are going eSIM with RSP capability, at least for an insurance model, right? Say, I can switch if I need to. I don't necessarily want to, but I can, right? And the last step of this evolution, right, is the integration, the integration of iSIM. iSIM today is mostly what we call single profile. That is, you load a specific connectivity at manufacturing, and that's the connectivity for the life of the device. but it's already possible to certify an integrated SIM which is multi-profile capable. So the so-called IEU-ICC by GSMA, but the standards exist. It's all there, and you have several supplier and chipset supplier which are on that route, Sequence, SSI, and so on. Yeah, this is the final step, I would say. So today the vendors, I would say, are evaluating this technology, but it's not yet in massive, metering deployment. Now the deployments are on the eSIM stage.
Yeah. Okay. Thank you, Loic. Neil, perhaps I'll bring you in. There's a few questions, if I can, on there's a few questions on kind of private networks and what's going on, I guess, with CBRS and Anterix in the US, particularly. I think Fabian referred to that. Just explain what that dynamic means with kind of liberalization of spectrum, with private networking opportunities for the metering market at large. Presumably, most of the activity is around connecting the grid rather than the meter in the property. Is that correct? Just talk around that.
Yes and no. It's a very good question. So we see the emergence of more private networks as this is made possible. And of course, the benefit of private networks is you have more control over the configuration of the network over this long period of time. And you'll also see the private networks generally operating in the low spectrum bands, which is also very important. So in the US, to my knowledge, they're mostly sub-gig spectrum, and across Europe, and in fact, a lot of the world now, we're seeing the expansion of CDMA, not CDMA, what am I talking about? of 450 megahertz. And yes, these are being picked up a lot by utilities for smart grid applications, but we also see them being adopted directly in smart meters. When you look at the Netherlands, yes, there's the utilities actually form their own private network on 450, which they use for both smart metering and the grid connectivity. So yeah, I mean, let's see what's going forward. There's a lot of initiatives, especially in the US, regarding connecting smart meters directly to private networks. And of course, with the eSIM, I think Loic was just talking about insurance cases. Well, this is kind of quite nice. This migration from public networks to private networks and back again. Of course, if you're on the edge of a private network, then utilizing the eSIM, you've got the opportunity to switch devices across different networks as you go forward. So I think eSIM is key to the adoption of private networks as well.
Yeah, okay, nicely said. That takes care of another question there. So thank you, Neil. Fabian, just to bring you back in, just NB-IoT and unlicensed LTM and unlicensed. That is what you're offering, isn't it? I mean, are there devices certified for that? You know, how close are you with that?
Okay, yeah, so indeed, so that's kind of specific to the North American market, or should I say the FCC region. Yeah. So that's applicable to Canada or Latin America as well. But as of today, it's FCC certified. So that's for the US only. So it's operating a LTM CAD-M1 base station in the unlicensed band that traditionally has been used by those short-range mesh technologies and a lot of technologies actually. So LTM is compliant to the FCC regulation. So you have some technical limitation, transmit power, so it's 1 watt, etc. But it is able to run there. And the beauty of it is that actually it does overlap with band 8, which is one of the most common band. I mean, it's the traditional GSM band. So it does overlap with the 3GPP band 8, which all the modules are capable of supporting. So they do not require any change to the software to connect to that LTM base station in the unlicensed band. It's a 3 megahertz chunk of the unlicensed band, very much like the Anterix spectrum is a 3 megahertz chunk of the band 8 as well. So you don't require any change. And that's something we've demonstrated with meter vendors like Itron, which are using modules from, could be Sequence, could be Sierra, could be Telit, those modules typically supporting CAD-M1. As for NB-IoT, no, it's not compliant because that's a narrowband technology. So the technical requirement for FCC and all other regions are different. So you cannot operate NB-IoT in this unlicensed band. And that's actually why moving forward, we are also planning to offer NB-LT and weightless in the same chipset, meaning that you will run NB-LT when you are on a private or public network, and potentially being able to move from one to the other, indeed using a SIM with multiple IMSI or eSIM, but also operate an unlicensed band, in that case using weightless, which has, I would say, in a nutshell, similar capabilities with NB-LT, except it's compliant with unlicensed band regulation.
Yeah, okay. We've got a few questions coming in. I don't think we're going to get to them. There's a couple there for you, Matt. So you might take names and take them offline a little bit. But we can come back post after this event to answer any more questions. If time is up, I'd just like to go around a little bit and just to finally, discuss how important the meters are, because I think they have a bit of a bad rap. They've been around a long time, but it strikes me this is where a lot of excitement is in the IoT space. Neil, perhaps we can go around. Perhaps we can start to you. Is metering the most important and most exciting market in IoT? Can I ask you that?
It is for me, but it's not the only. It's not the only exciting application addressed by IoT. But it's a critical infrastructure. It's critical industry, and it's critical infrastructure, which kind of makes it attractive. And if we don't do something, then we've got a big problem. So the world has to adopt. Smart metering. Otherwise, our children aren't going to thank us for it. So that, to me, kind of makes it exciting. And the thing that also makes it exciting, it is kind of this crossover between the industrial world of smart grids and the consumer world of smart homes. And so everyone notices it going forward. And that's, for me, what makes it very interesting.
Brilliant. Matt, can you say something on that? I mean, that does seem where
I have to agree with those sentiments. Yeah, you'd argue that other sectors are more important for certain things. Perhaps from a revenue perspective, the automotive sector might be more important to you, or consumer electronics if you're a hardware manufacturer. From a sustainability perspective, there are a few things that can compete. So I'd say generally it's one of the more important IoT sectors across the board in any way of viewing it really, even from a life-saving perspective as well, right? So in a lot of countries, theft of electricity is quite important, and monitoring the usage of electricity and stopping people from perhaps doing things they shouldn't be with mains electricity. It's all part of that. So it's important in all manner of sectors. And sometimes quantity has a quality all of its own, doesn't it? Right. So I think from an interest point of view, it's very interesting from an analyst perspective to look at the market, seeing these huge $billion contracts change hands and billions and millions of smart meters being deployed in different countries.
Yeah, and Fabian, just quickly, I mean, there's lots we haven't discussed in this session. The report will hopefully expand on some of this. But Fabian, just as well for you, I mean, it seems to me that you've kind of struck a rich seam of innovation in this market. Just how do you view it? Well, what's your sense of it in terms of its importance and excitement?
Yeah, I agree with what has been said. I think that's actually increased in criticality. We've kind of taken access to energy as a given, maybe for some time. Now it's really on the map, and we know we need to manage that, optimize it. So it's becoming more and more critical. So in that sense, that's getting more exciting in the sense, yes, that it is becoming very important. It's not necessarily the fastest moving industry, as a vendor trying to actually sell products and bring innovation to that market. There are challenges because it's traditional utility companies might not be the fastest moving, but we try to excite them with new innovation and new ways to do things. So it is still exciting as well.
Brilliant. And Loic, last word to you on this market, and I guess the meaning of it for the eSIM revolution as well. Can you put it in words for us?
Yeah. So I would underline, Neil did touch on that already, but for example, scarcity of resources and water. I think water Matt made the point of this is the fastest growing out of the three, I would say, in terms of number of units. And I think access to water will be critical, and we can help with our consumption habits there. And to maybe also complement a bit Fabian's point on innovation, I think it's a sector which I think is ready for some disruption, right, in the way energy is distributed, shared, consumed, right. So one example I have is a collaboration we had with Energy Web, which is about a marketplace, a global marketplace where energy suppliers, producers, whereas you're big or small or an individual producer, can have a marketplace to share and exchange, access to resources, right, and use security to have secure transaction and a place where they can do that efficiently, right. And I think that's a market which should start to look at this type of innovation to already optimize the sharing, notably, and the usage.
Look, brilliant. Thank you, everybody. Look, I'm sorry that I didn't get to more questions. I assure you that most of them, if not all of them, will be answered in the report out in a couple of weeks. It's a fascinating discussion. There is a lot to it, and I really appreciate your time. But for now, thank you, Neil from Telit Cinterion, Fabienne from Ubic, Matt from Transformer Insights, and Loic from Kigen. Thank you so much for your patience and your time. And thank you all for tuning in, and we look forward to seeing you again. Thank you. Bye.
Thank you.
Thank you.
Thank you. Bye-bye.